We're recording the session as usual. Today we're going to talk about XXE attacks. It's based on XML, so most of today's lecture is based talking about XML. And eventually we'll get to XXE, which you'll never understand if you don't understand XML. So let's talk about XML. So unless anybody has any questions, let's move on to the material. Okay, there we go. Everybody can see our slide for today. Well, maybe. All right. Hopefully you see the words XML on your screen.
Yeah.
Okay, good. Thank you. It's not real clear from my point of view what you see and what you don't. All right. So we're talking about XML and XXE, which we'll get into a little bit later. All right. XML. Many of you have probably used this before, but I'm going to go over some of the details because some of the more vague and not as popularly used aspects of XML are involved in the XXE attack. Okay, so XML is the extensible markup language. And if you look at it, and we'll show some examples shortly, it looks very much like HTML, but it's not HTML. It doesn't display the information. HTML is designed to define how information should be displayed, whereas XML is used to transport information and store it. So it's have a different purpose, and so it looks different. XML is what they call self-descriptive because you have tags that define what the information is, then you have the information. And like many other things, it's a W3 World Wide Web Consortium recommendation. It's got a standard. Okay, and as I mentioned, it's not HTML, even though it sort of kind of looks like HTML. They're both markup languages. Now, HTML has a set of tags. You know, you can have a IMG tag for an image, or you can have a div for a division. And there's a fixed set of tags that can work at HTML. Not so in XML. XML, you can make your own tags. You can create whatever tags you like. Here is an example XML file. By the way, these slides for today, as always, or as usual, sometimes, are out on Blackboard, so you can follow along if you like, or just read the slides and skip this lecture. But here's an example of XML. Typically starts with the XML prefix, which I'll talk about shortly, a prolog coding. And then we have tags. The tags, like other language, start with the brackets, and then end with the bracket slash, the same name. So this one's a student. And inside the student, there's an ID, there's an address. And inside the address, there's a street and a city element. The address has an attribute. This is an attribute where it has a name equals and a value. So this is your standard XML file. The first line is the XML Prolog, which is optional. You don't have to have the XML Prolog, but if you do have the XML Prolog, it must be the first line. XML is case sensitive, unlike HTML, where you can type the tags in upper or lowercase any way you like. XML is case sensitive. You make your own tags, then they are case sensitive. So beginning must be lowercase XML, bracket, question mark XML, and it ends in question mark bracket. And you give the version, which is almost always 1.0. I do not know exactly what the current version of XML is, but 1.0. And then the encoding. The encoding tells what file format. UTF-8 means it's 8-bit format. That's very standard, previously known as ASCII. Okay. As I mentioned, you can make up your own tags in XML. Whatever you want to use, you can define that in your file. Note that the tags are case sensitive. If also the tag names follow the usual Java, C++ sort of name rules, has to begin with a character, can contain letters and numbers, no spaces, no weird characters. Yes. Now, there has to be a root tag. That is a tag. If you look here in the example, student in this case is the root tag. There's one and only one of these, and it must start. So it's usually, well, not usually, it's always the first tag after the heading. Okay. HTML is pretty loose. You can make all sorts of mistakes in HTML, and your browser won't complain. It'll just display the stuff as you want. There are tools on the web to check and see if your HTML is properly formatted, but if it's close, it's usually good enough. XML is not like that. XML requires that your file be properly formatted. They talk of a yes question.
So for like when you have things like Angular, how does that work? You're able to have like custom tags.
I'm sorry, I couldn't hear you. Could you try that again?
Angular, I have a question for like how does Angular work? Because it has like custom tags in the HTML that's into your browser.
Oh, okay. You can mix XML and HTML. XML, whenever a file is supposed to be formatted in XML, it has to be properly formatted. I'm not sure I really understood your question. Oh, well, let's go on and see if maybe I accidentally answer it. Okay. Yes, but more about the format. They have a well-formed, they talk about a well-formed file. Well-formed files have to be properly nested. That's just like brackets in any programming language. They have to be appropriate. If you have an element A followed by an element B, and then the end of element B, followed by the end of element A, you have to do it in that order. In other words, you have start of A, start of B. You can't have the end of A, then the end of B. Nope, it won't work that way. All start tags have to have an end tag, unlike HTML. That's one of it seems to be violated most often. You can have short tags in XML that have the backslash at the end that terminates the tag. As I mentioned before, the names are case sensitive. And attributes, which we'll talk about shortly, but the values must always be in quotes. Okay. You can have comments, and I, as an old programmer, strongly recommend putting comments in your files whenever there's a question about anything, or even in the beginning, say, what is the purpose of this file? In XML, comments start with a greater than sign or a left bracket, exclamation point, dash, dash. So you can have 4 characters to start it. And it ends with a dash, dash, right bracket. So those are XML content, and they can go for multiple lines. Very much like the /*/ comment in Java, C++, JavaScript, all sorts of languages, PHP. And also JavaScript and PHP support the comment format of / to the end of the line. I mention this in particular because if you are writing programmers that are using XML, JavaScript, and PHP, the languages are somewhat similar, but you can get confused sometimes. You go, oh, how do I put a comment in this thing? And I must confess, I've put /* in XML files only to find out that's just data. Fortunately, if you have a good editor, it will color your comments in one color or another, and you'll notice it's not the right color. Okay. Although my personal pet peeve with PHP and JavaScript is concatenation. Well, that's another issue. Okay, elements. An XML file is a collection of elements. An element is a tag followed by everything up to its end tag. So here, course, and everything between that and the end course is an element. Elements can contain other elements. You can have, in this case, the course element contains a number and a CRN. In other words, it has 2 other elements within this element. And you can, of course, nest them to whatever depth you like. So they continue to have one element to another. And typically, XML files for real applications start to get kind of deep. You can have attributes. An attribute is further information attached to a tag. It is attached to the opening tag, not the closing tag. Here we have defined is the attribute, and the 201820 is the value. The value must always be inside quotes. So CRN element has the data of 20029, and then there's the N for that. And then inside that, we have an attribute. So you can have both attributes and data. Now, you can put all the information in attributes if you want to, or you can forget attributes and just create sub elements to do that. Both ways work. In most of the information I've read about XML, it strongly recommends that you keep your data in the data part of the XML file and use the attributes for metadata, for additional information about the data. Not data itself, but something about it, metadata. Okay, and there's all sorts of things that a XML file can contain. Character data can be represented in a couple of different ways. C data represents character data that is not to be parsed. In other words, it's got anything you want inside. PC data, which is not, which is data that will be parsed. And so you have PC data written in uppercase. So it may have other tags. So if you have PC data, it may have elements and sub-elements and further sub-elements in it, whereas C data just has data. So if you have politically correct data, it has just everything, typical XML data. Okay, now if you put the data in there, you probably want to have, you want to encode XML entity encoding to change the usual problematic characters to their, well, HTML style abbreviations. So these things will become that. You've probably seen those before. Which brings me to my first question for today. What if you don't do that? So click away. All right. Okay, about 3/4, oh, 80% of you have answered. A couple holdouts. Oh, it's only been 15 minutes of lecture. You couldn't have fallen asleep yet. Maybe you could. All right. Okay. Well, that's enough for now. Let's end the poll. Let's let everybody see the results. Hopefully you can see the results. Well, we have a variety of answers. Somebody clicked on everything. The most popular answer is that the file is vulnerable to an XXE attack, which you would imagine to be correct because this is a lecture on XXE. But that is not the answer. The answer is B, data values could cause a parse error. Yes, let's think about that. And okay, hopefully you are back to the slide that shows encoding data. You can imagine that your data might have a less than or greater than sign. Particularly problematic is the, well, I guess the less than sign. Because if you wanted to say like cat is less than dog, you put that in your data, XML will interpret that less than sign as the start of a tag. And that will cause an assortment of difficulties. So you want to, your program should do some HTML encoding. I'll show some examples later on. Okay. Now, frequently you'll see XML files written on separate lines, nicely indented with the data. This is lines up that, and you don't have to do that. In fact, if you do put it like that, note that XML keeps track of all the white space. In other words, unlike HTML, which pretty much ignores additional white space, one space in HTML is as good as 100, but in XML, it preserves white space. So in fact, the tag secret has a whole bunch of spaces or tabs before the word my stuff. And then my stuff ends with a new line. Foo has data, has some spaces, a new line and some spaces, and then some more over here. So all that is preserved as data. So typically one does not really want that. So you might want to squish, depending on it. Now, if it doesn't matter, it's nice to be able to look at it in an easily readable way, but it may make a difference. So you can take out all the new stuff. And here in my example, I squished out all the spaces and tabs. And therefore, when you analyze that program, when a program parses that XML file, it will not find any data under foo. It will find only the words my stuff in the secret element. It won't be space, 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 my stuff. It'll just be my stuff. So I discovered that one while working with XML. Okay. Namespaces. You can, as I said, define your own tags in XML. And there are also other XML library systems that have a bunch of tags that you might want to use. And of course, there's always the possibility that you'll overlap, that tags you're using, tags that are defined by some other system will overlap. To avoid the problem, you can have a prefix. In other words, you can say this prefix defines a group of tags that you're going to use. So in this case, XML-NS is an XML namespace, colon, and then pick a name, make some sort of name equal to a URL. And then when you use that name that you defined here before, colon, before the tag, then that's the prefix. And that means this tag belongs to that NCAT group. And so you don't have to worry about number or CRN overlapping with anybody else's names. You can also, if you want, define a namespace without using the tag. You just go XML, put the URL, and that defines a default namespace, meaning all of the tags in your file will follow that namespace pattern, that namespace requirement. I think I said this thing. The XML, okay, the XML is actually defines a prefix for all of them. The attribute, yes, you might notice this has a URL here, but you don't have, doesn't really have to exist. This is, I took out NCAT and put in NDOG. It doesn't matter. This is just an identifier. Now it has to be an identifier in the form of a URL. And some people put information out there about their files, but it isn't required. It doesn't look at it. I mentioned I wrote a program a while ago, about a year ago, to keep my passwords safe. I got a whole bunch of passwords for all sorts of things, and trying to be secure, I don't reuse passwords. So I wrote a program in Java to keep my passwords, and I store the data in an XML file. XML worked really well because in this application, I have a bunch of tags or values, not values, identifiers, and then the values. In other words, this thing is a note, and that's the value. This is password and the value, which you don't see. It hides that. And I have stuff. Yes, this is hidden. Yes, again, I use an XML file for that. The XML file has an attribute on the data values and say, should you show this data value? It's the attribute is called display, which is true or false. If it's false, then it doesn't show that value. It just shows it as the classical stars. Always, by the way, 12 stars, doesn't matter how long the value is. It doesn't give you any hints. If you click show, it will show it to you, but it doesn't show the value on the screen. The C value button over here copies this value. So it does copies that into your clipboard. So what's nice is you can keep a password and then you don't have to look at it. Click C, copies it, then you can paste it into a logon screen, and you don't even have to look at it, which is nice because it also has a feature. If you create one, I'm not going to show you that. If you create an element, it will make up a random password using whatever character sets you like. And the random passwords are really random and very difficult to memorize, but that's okay. You don't have to memorize it. If you want to go back to the site, you just go to this page, search for it, press the copy button, click in there, and you can log in. You don't even know your own passwords, which works well until you go to a different machine. Okay, so of course, I wanted to keep the information secure, which brings up another question. I use this XML file, and then I want to keep it secure. So how is the best way to do that? Here's another poll. Think about this for a minute. You have to put up with these questions so I don't use them on the exam next week. Okay. Well, there's one person who hasn't. Oh, we got them all. Perfect. Thank you. All right. Let's look at the results here. The most popular answer is encrypt, then compress, which is incorrect. Hey, you're 0 for 2 today. Gotta do a little better. Okay, you want to compress, then encrypt, and the order does matter. Let's think about this for a minute. When you encrypt a file, you take a file that has a lot of order to it. English has got some order. When we think about encryption, think about the fact when you text something, you get your phone out and you send a text message. As you type a word, your phone gives you suggestions. And a lot of times, if you're sending a text to somebody not much different from previous text messages, it'll suggest the next word. In other words, even though there's hundreds of thousands of words in the English language, it's likely you're going to use the next word. And so encryption, or excuse me, decompression takes use of that fact. There's a likelihood that the next character is going to be something particular. And so it's not a whole millions of possibilities. It's actually a small number of possibilities. And there's an escape in case it's one of the weird ones, but that's how compression works. So it relies on the order of the file. Now, XML files have lots of brackets, and the tags may appear many, many times. And so it can compress those down to small things. When you encrypt something, it takes a file and turns it into something that looks like random bits. Well, random values do not compress well at all. In fact, a totally random file does not compress, period, because the compression algorithm can't figure out what might come after it because it's totally random. So if you encrypt it first, you take a file with lots of order and produce a file that's encrypted, or excuse me, encrypted but random, and then it won't compress. But if you compress it, of course, XML compresses quite well because it's got lots of repeating data, and then encrypt it, it'll become small and safe. So, okay, everybody understand that? Any questions about that? All right. So, I'm 2 for 0 now. All right, so we didn't talk about compression in the class, but I just thought I'd throw that out. Okay, so that's an example of using XML. Of course, in this particular case, by the way, I primarily use XML because it was easy to search and easy to find data. It's like a database in a sense. There are tools that help you use XML. There's a XQuery for searching like your database. Yes, I use it so it's easy to find things in there and provides a lot of format. I don't obviously it's a password file. I don't share it with anybody. Okay, there are a whole bunch of XML tools, XML programs related to XML that you can use with XML files. There's a system called XPath that can be used to describe a part of an XML file. If you want to describe it, pretty much because XML is a tree. The data is a tree, very much like a file system is a tree. And so the XPath describes the XML files very similar to like you're looking at a file system. The paths are the higher level elements down to the leaf elements. In fact, they use slashes. It looks just like a file name or a file path. XML XSLT is used for transforming XML into HTML if you want to display it. XQuery is a language for querying an XML file. So if you loaded an XML file, you can then run searches on it. XML document type definition is used to specify what elements and what format the elements may occur. We'll talk about that in detail in just a minute or so. And then schemas is a more powerful way of specifying the format than DTT, although DTT is a more well-known standard. There are many other tools involved in XML, but we're not going to cover those today. Okay, as I mentioned, you can specify a document type definition. Because in XML, you can make up your own tags. You can always have your own tags and your own attributes, whatever you like. But if you're going to share information with other people, or more importantly, with other applications, if one application is going to send data to another application, it ought to be in a format that both applications understand. That if one application is going to have a tag name and the other one is going to have first name, last name, it's not going to work so well. So you can define how the tag should be, what tag elements you can have, what elements you're allowed, and what attributes are allowed, in what order, what child is the child of what other element. That can be defined by a document type definition. And the document type definition can be stored either inside the XML file in the beginning or in a separate file. Okay. So if the document type definition and stored in the file should come immediately after the first line. In other words, the XML Prolog is the first line, so the DTD header is the second line. And it starts with bracket, exclamation point, doc type. That's in capital letters, remember this is case sensitive, space, and then root, where root is the root element of the file. Remember, that's the first element in your file. And there's only one of them. And so specify the root there. And then there's a square bracket. This is followed by a bunch of other definitions of what you want to do, ending with the right square bracket and a right angle bracket. So it's kind of like an array. So that's a specification of the different elements that you can have. And it starts with that. Okay. Now, all the elements of the XML file can be defined in the data type definition to say that these elements can appear in the file. And the DTD definition is pretty straightforward. It starts with exclamation point element in capital letters, and then the element name. This is the tag name that appears in the XML file, followed by some sort of category, what kind of data or what is going to be in this element. You got to specify what do you expect to see in this element. And there's all sorts of things. Any means, well, it can be anything. That's pretty clear. Pound, parentheses, pound PC data, right? Parentheses says it's going to be parsed character data. That means there may be further elements, further childings. Empty meaning there's going to be nothing. This tag can't have anything inside. And there's several other types that I won't go into. One of them is you can specify a list of possible values. I'll show you an example here. Here is a list of for the example I gave earlier for the student thing. So we start again with this exclamation point doc type, and this would be the second line in the file. And then student, because student was the root element bracket. And then we have student elements are followed by child. These are the children elements. So we're specifying what children can be in a student element. And so the direct children of a student, you can have an ID, you can have an address. And an ID just contains data, just data. Actually, it just contains numbers. We could have specified that, but I just put PC data. And then there's an address value because we have IDs and address. The address value has two further children, street and city. By the way, you don't specify street and city up here because street and city have to be inside an address element, which is inside a student element. So street and city, I think both of these just contain data. So this defines a structure. In other words, there's a student element, which is the root element. And inside student elements, there's ID elements and address elements. And inside the address, there's streets and cities. And shouldn't be anything else. You can also define attributes. You can restrict what's going to be in an attribute. And that's done with the ATT list, again, exclamation point. And then there are several values here. First one is the element. What is the tag element that this attribute is going to be in? In my example, address was the tag, and then on campus was the attributes. So this is the tag in the XML file. This is the name of the attribute in the XML file, which will say that attribute name equals and then some value. And then this is the type. What kind of data is going to be in that attribute? Remembering that attribute values are always inside quotes. And then here is a value, a default value for that. So or the value can also be several types. Pound required means you have to have this attribute. Every element that appears in the XML file must have this attribute, or you get an error. Implied says it's optional. Fixed value means it's got to have that value. CData is using the most popular value that you'll, or type that you'll see here. And here's an example of the address element in our. So we have the DTD here to create an element. We're going to see address, and it has a street. We saw that before. And now that address can have an on-campus attribute. And that can be true or false, the default value of true. And so here is how it would look in the XML file. So again, we have the address value on campus equals false, because that's one of the possibilities. Okay, so it defines that. So you can't have any other values besides the on campus. Another thing that interesting you can do with DTDs is to define an entity. An entity pretty much defines your own escape sequence. Starts with exclamation point entity, capital letters, and then a name, and then a value. And what it is, it's going to look in your XML file data, and in the data where it finds an ampersand, the entity name that appeared here, and a semicolon. That will appear whenever you find that in the data, it will replace this with whatever value you have here. I use an example down here. I've got an entity AT. AT is the tag name, and it's going to replace that with North Carolina A and T. By the way, this, of course, is the HTML encoding for an ampersand. So someplace in the data, I could put ampersand AT semicolon, and that becomes North Carolina A and T in the data. This is particularly useful. It's a shortcut. If you are going to write that frequently and you don't want to type it in frequently, you can put that there. Also allows you to change it later and change it in every place. Okay. And you can also, in an entity, well, before we specify just the text, you can specify that the values for that entity comes from another file. So here we have entities before. Stuff, again, is the tag, and you use it in the XML file, be ampersand stuff semicolon. and then system, the keyword system, and the name of a URL where it will find that, which could be a file, a local file, or in this case, it's a web reference. And when it finds ampersand, it will go out, the parser will go out to this file and add that, replace that. This is why we're here today, because this is the source of XXE attacks, which we'll talk about in a little while. So this is where the problem occurs. We'll go over this in more detail. Your data type definition can be located in the beginning of a file, an XML file, or it can be in a separate file, typically with the extension of .dtd, and that makes it a little bit easier to use. You don't have to put it in the beginning of every file, particularly if you happen to have several files that use the same document type definition. And you put the document type definition, all the element statements go into a separate file, except for doc type. Doc type remains in the XML file, and you just say doc type student, because remember, student is the root element system, and then specify that. And when you do this, the parser will go out, read the student.dtd, and then when it parses the file, it will make sure it follows the rules specified by this. Okay, any questions about that? Everybody understands this DTD stuff? No questions? Well, in that case, let's give it a shot. Let's see, there are 19 participants. It's me and 18 others. If we divide us into groups of 3, there'll be 6 groups. So I'm going to use the old Zoom breakout feature here, I think, if I can figure out how to do it. Breakout rooms and break into groups. I'd like you to write a document type definition and an example. I was write an XML file with a document type definition and show how you could create. Now, the file is supposed to hold a bunch of pets. Each pet has a type, an animal name, and a name like George or Lassie or Rin Tin Tin. And then also, you need to specify occasionally whether that type of pet is dangerous. Okay, everybody understand what we're trying to do? Yes. Okay, hopefully, yes. Well, there is my solution. Oops, I don't know if you can. Yes, all right, it's an XML file. I only have one animal in here, but I have the document type definition. Now, of course, there are multiple correct solutions. So this is just one possibility. Pet is the main, is the root element. Now, you can only have one root element. And since we have multiple pets, I had to create another element called animal. So everything in here is an animal. And inside animal, I have the type and the name. Type being whether it's a dog or a cat or whatever. And then the name being whatever the name of the animal is, Lassie. So this is a dog. And then in order to capture the dangers, I just said true and false, although somebody suggested danger level, because that's probably even better than true or false. Anyway, I said dangers can be true or false, and I specified this is an attribute. So that's it. I just say I save this in as a text file. If I was smarter, I would have gone down here and said this is an XML file. And yes, the nice thing about it is it colors it and indents it and other stuff. Okay, so there's it. Anybody have questions about that? Hopefully did you get a solution that was different than that might be interesting to look at? Sorry, somebody spoke. I couldn't hear you. Yes.
400. 400.
Anissa, I couldn't hear you very well. Could you try that again? I guess not. Okay. Any other questions on this? I'm sorry, I couldn't hear what you said. Crank up my volume. All right, nobody has. Well, all right.
I do have a little question. So for the animal type, couldn't you just say something like pet type name instead of animal? Would that be
okay.
optional, or?
That's an interesting solution. The problem with that is you have to remember you're only allowed to have one of the root elements. So you need some kind of root element. I could have had a root element like zoo or home, and then have pet types. But because see here in my example, pet is the root inside. So you have to kind of add another layer, or at least there has to be a root that isn't repeated, because you can only have one of the root elements.
Oh, okay. Thank you.
Okay, yeah, that's a yes. To the untrained eye, one would have thought, yeah, just have a bunch of pets, but it doesn't like that. It gets a little upset with that. Okay, well, let's move on. We've got other things to cover. Let's stop sharing that, and we'll start sharing the slide. Okay, so there we are, moving on. Maybe. Okay. AJAX. AJAX is a system that sends data to a server, and then the server responds back to the client. It's it's the technology used by most modern web applications. It's basically the idea of using an XML HTTP send, which is of course intended for sending XML. It doesn't have to be XML. Most AJAX systems now use JSON instead of XML files, but yes, the idea was a web application. The browser would send an XML file to the server, which you get that data, look at it, do something, and send back another XML file to the client, which could then display the information on the screen. Same thing we do now, but typically we use JSON. Here's a comparison between a JSON file and a XML file. This is the same assignment. We've got pets, and instead of animals, I have critters. Here is the JSON version at the top. And you can see JSON, of course, is usually parsed and converted into a JavaScript, in this case, a JavaScript array. It's a pet object, and it has two elements in it. One element has a dog named Fido and a cat named Kitty. I didn't have the attribute in this one. Here in XML, we have the XML version, and you can see it's got a lot more. Interesting to note, counted characters here, and there's 71 characters in the JSON solution, and there's 156 characters in the XML solution, which is more than twice as much. Now, of course, as it got bigger, the ratio changed because there's some overhead here with the prefix or prolog, the pets, not pets, but each element has to have the critter, whereas it's a little later here. All we have is curly brackets to define a element instead of the square brackets, and the whole thing is defined by one square bracket. So both of them accomplish the same thing. They just do it in different ways. People tend to be moving to JSON away from XML, although XML has some advantages in that it's self-describing and you can enforce it. Now, examples of how you use an XML file in different languages. In PHP, because typically you send these to servers. Of course, servers run PHP or Java or JavaScript or Python or whatever you like. I was using PHP, so here's an example. XML in is doing a get, so it gets this from the command line. In other words, we're doing a get request to the server, asking for some information, we're sending an XML file to the server. So XML in contains a string of the XML file. And then XML document class, we call the load XML method, passing it the string and an option. Now, this option is supposed to allow you to have external entities. You don't have to have that there. You can, in fact, leave off the options, and there are other options that you can put on there. And then once this works or doesn't work, as the case may be, you can then get individual elements from the file, but this XML doc object here, calling a method on it, get elements by tag name. Yes, it follows the domain object model, very similar to the domain object model for HTML. There's a domain object model for XML, and same cuts. We're going to get elements by tag name, and you give it the element name that you're looking for, and it returns a list of those XML elements. Here it is in Java. In Java, of course, there are multiple parsers. Yes, and there are multiple parsers in PHP and in other languages. This is the one. There are several in Java that I've used. Excuse me. Okay. Here, in typical Java fashion, we have the document builder class. Sorry. Oops. Cough in your ear. We're creating a document factory object. On that document factory that we built, you don't can't just create a new one. You have to go new instance. So it creates a new instance. So now, doc factory is a document builder factory from the parser package. And then we're going to build a document builder, which we do from calling the document builder on that doc factory. So now we've got a document builder object. And from that document builder, we can then call the parse method and pass it a string that contains the XML. And it will create a document object. So now the document object now, or by the way, at this point, it won't work for some reason. It may give you an error, but yes, this now the document, and you can call methods in the document very similar to what you did. I have an example. Let's try looking at the Java program, wherever the Java program went. No. Oh, okay. Sorry, it was hiding on me. There it is. Hopefully you can see this is JGrasp. Those of you who took Comp 163 will remember JGrasp. Yeah. So again, in this example, there's the building package. And then there's the parser built up here. In the middle, I am setting, or the case may be not setting, a couple options. There is a attribute you can set that allows you to specify that will deny access to external domain data types. So the external, the item that causes the XXE threat, you can turn that off. I have it turned on. By default, it's on. I have not turned it off. If I comment this line out, it will turn off. And then I have validating true. Now that's very important because validating means that the parser will enforce the data type definition. In other words, the data type definition says you can have these particular elements. If you don't have those particular elements, well, it won't work. You'll get an error. Let's see. And then after this, I've got this method here that displays the node, and it goes on and on and on. Yeah, we don't need to see that. But it displays the information. Let's give it a shot. We'll try running it and hope for the best. It's going to compile it. Hey, no compile errors. Let's try a XML file, simple XML. And first, you notice the simple XML file does not have any data type definitions. So the validating parser says, hey, this thing has these things you never specified they're going to be there. Okay. The program finds the root file is foo. Okay. And there's one element. Element has and there's data is my stuff. Okay, if we, let's hang on here, we're going to change the sharing type. And stand by, we're still figuring out how to do this. We're going to share screen one. Okay, here we are. Now you can see, here is the simple thing. You see, it's really simple. Foo, secret, my stuff, that. Interesting to note, you notice I have it printed on separate lines. So my secret is actually new line, my secret, new line. And so when it parses here, it comes out, the program, the first thing the program does after you get all is it prints out all the text of it, all concatenated together. And so you have some new lines. And then we go and look at it and say, yes, there's a, says there's an element foo. Inside that, there's an element secret. The element has data, and the data is my stuff, which again has the new line. All right. Questions about that one? Let's try a bigger one. Let's try running this with a Java, or excuse me, an XML file that has a data type definition here, very similar to what we had in the example. We have the student, it's got a data type definition, and all that. So we're going to run this, and that's voila. All right. Now, line 18, it gives me a warning. Element type student must match, parse correctly. Yes, that's because the data type definition, I said student contains an ID and address. I didn't say it contains any data, and we have some data in here. And so it's complaining about that. If I take the data out, I think it will stop complaining. Let's give that a shot. Here's my example. Take Fred out, take out the name, save that, go away. We'll run this again. Maybe. It's XML. And here we go. Yes. Hey, no runs, no hits, no errors. It didn't get any errors in that one. So this, which it means is the validating parser said that this XML file meets all the requirements. In other words, all the elements match. In other words, it had, a student has an ID and an address, and short off, and all the. You might also note that I had the ampersand at AT, which then expanded over here to North Carolina A&T. Okay, questions about that? Does that make sense? Now I have one more example. Let's run the other example. Okay, let's look at this one. This one is using an external data. Do I have that? Oh, I don't have that. Let me see if I can open that one. There is the external data type definition file. In other words, that, and then yes, this one's going to reference it. This one has a doc type, but calls on a different file. So let's try this one. That was clean X. So let's run it. Press the run button. And yes, okay. It worked fine. There was no errors. It parsed correctly. So the data type definition was read in from another file that was specified. It worked. Any questions about that? Okay, hey, my program worked. How about that? That's a cause for celebration. All right. So let's go back to sharing just the output. Okay, go where. All right. As I mentioned, there are options for the XML parser. You can specify whether it's going to validate the DTD. Now, if you don't have the validate or verify option on, then the DTD is pretty much ignored. In fact, except for the entity elements, everything else is ignored. It doesn't care if you add extra elements, spell the names wrong, it's not going to say anything. But if you turn on the verifying option, as I had on in the example I just showed, then whenever you have a XML file that doesn't perfectly match the data type definition, it's going to give you some errors. And then again, there's the external option that says, can you or can you not go out and grab files from another location? Oh, okay. And here, you can also say that you want an entity when you have an entity. Remember, in this case, we have stuff. So anytime there's an ampersand stuff semicolon in your file, it will go out and get this file or URL. It will put that in the XML file. So the XML ExternalEntity Attack, which is the XXE Attack, which is the focus of today's lecture that we finally get to on slide 34. We finally get around to what we're talking about. Yes, this is an XXE attack. This is when you have an external entity like this. It's going to go out and it's going to copy the contents of that file into the XML file. Now, if you can get some sort of server that's going to return the value of that XML file to the client, then you can find out what's in the file that you asked for. Now, remember, because the parsing occurs on the server, it will run with the access rights of that server. So there may be files on the server that you cannot get to as another individual, but the server can. There's files that are outside of the HTML directory, and it can be accessing those. And so that will, so if you send it a file, let me see if we can't find another example of that. Oh dear, it's not there. It's I have so many of these. There. Here's an example that works just fine. Out on the file, I have so. Let's try this. I really tried to make a server application that would do this, but let's assume that we have one and that you're going to upload an XML file to the server, and the server is going to return data, and you want it to return the secret.xml files located on the server. And for the sake of simplicity, we'll assume it is in the same directory as the application. So we want to get that file. Try to create an XML file with that application that will do that. So let's try the breakout. We're going to make this a short breakout today, this time.